previous examples, we looked at balancing redox reactions in acidic conditions. Now we want to look at and see how things change when we have basic conditions. So one of the issues with just using our rules for acidic solutions with basic solutions is that we often end up with H pluses in our balanced redox reaction. And if we have basic conditions, producing H plus or having H plus on either the reactants or the product side is problematic because it's not going to be stable. It's going to react with the hydroxide from the solution being basic, and it's going to end up making water. But there's an easy fix. We can balance the redox reactions exactly the same way we did in acidic conditions, and then we just add 2 steps to the end of that to make it work for basic conditions. So we're balancing redox reactions in basic conditions. First step, which is really like 7 steps, is balance the redox reaction in acidic conditions. And then if we have H pluses in our balanced redox reaction, I need to get rid of them. And the way we do that is for however many H pluses we have, we'll add that number of hydroxides to both sides of the equation so that it remains balanced. And so the side that had H plus on it, when I add OH minus to that side, those are going to combine to make water. And so then the last step will be to recheck and see if I have waters on both sides of the reaction now and cancel those waters out. Alright, so let's do an example of balancing redox reactions in basic conditions. Alright, so I've got my redox reaction, and the first thing I'm going to do is I'm going to balance it as if I was in acidic conditions. So you may want to get out those rules that we had, and step 1 of the rules is to assign oxidation states to every element in my redox reaction. So let's go ahead and do that. So I've got 0 for that aluminum, plus 3 for that nitrogen, minus 2 for those oxygens. Now minus 3 for that nitrogen. Hydrogen will be plus 1, aluminum plus 3, and oxygen minus 2. So we can see the element that was oxidized was the aluminum, and the element that was reduced was the nitrogen. So my oxidation half reaction is going to be aluminum goes to AlO2 minus, and my reduction half reaction is alright. So I usually balance them one at a time. I think in the last examples I might have kind of done the same thing to both half reactions and then gone on to the next thing for each half reaction. But in this case, let's just focus on the oxidation half reaction first. So first we balance the elements that aren't oxygen and hydrogen. That's the aluminum in this case. Aluminum looks good. I've got 1 on each side. So then we balance the oxygens by adding waters. So I need to add 2 waters to the reactant side. And then to balance the hydrogens, I need 4 H plus on the product side. And then to finish balancing the oxidation half reaction, I need to add electrons. And so my total charge on the reactant side is 0. Total charge on the product side, I've got 4 plus minus 1. So I've got plus 3 on this side. So to make the charges equal on both sides, I'll add 3 electrons there. And so my oxidation half reaction is balanced. Now I'll do the same thing for the reduction half reaction. Start with the nitrogens. They're good, 1 on each side. So then for the oxygens, I'll add 2 waters to the products. To balance the hydrogens, I have none on the left. I have 3 plus 4. I have 7 on the product side. So I need 7 H plus. And then finally for the electrons, I have a total of 7 minus 1. I have plus 6 on this side, I have 0 on the products, so I'm going to need to add 6 electrons to the reactant side. Alright, so each of the half reactions are balanced. Before I can add them together, I need to make sure the electrons are going to cancel. And so I need to multiply the first half reaction by 2. So then I'm going to have 4 waters, 2 aluminums, 2 AlO2 minus, 8 H plus, and 6 electrons. Alright, and so just so when I go to add these together, I'm not going to get them mixed up, I'm going to go ahead and scribble out that one so I know I'm not taking things from the wrong place. So then when I add everything together, I'll have 4H2O, 2 aluminums, 6 electrons, 7 H plus, and an NO2 minus on the reactant side. On the products, I'll have 2 AlO2 minus, 8 H plus, 6 electrons, and ammonia, and 2 waters. Alright, so let's cancel. So the electrons cancel, as they have to, or we've done something wrong. For the H plus, I've got 7 on one side and 8 on the products, so those 7 will go away. Those 8 H pluses will reduce to 1, and then I have the waters, 4 on the reactants, 2 on the products, so the 2 on the products will go away, and I'll have 2 H2O on the reactant side. So after canceling everything out, I'm left with 2 H2O, 2 aluminums, an NO2 minus, Alright, I think we have everything, and so let's see, make sure it's balanced at this point. I have 4 hydrogens and 3 plus 1, 4 hydrogens. I have 2, 3, 4 oxygens compared to 4 oxygens, 2 aluminums, 2 aluminums, 1 nitrogen, 1 nitrogen. So the atoms are balanced. The total charge on the reactant side is -1. Total charge on the product side, 2 negatives and 1 positive, so overall it's -1. So my redox reaction is balanced, but it's balanced for acidic conditions. And so I can't have this H plus if I'm in basic conditions. So let's go to the next slide and see what additional steps we need to take to make this appropriate for basic conditions. Okay, so I've just rewritten our balanced redox reaction in acidic conditions, so we've got it on this slide. And then the way we modify this for basic conditions is that for every H plus I have, and I should only have H plus on one side or the other, and so in this case it's on the products. However many of them I have, I add that same number of hydroxides to both sides of the equation. So I have 1 H plus, so to neutralize that I need 1 hydroxide. So I'll add 1 hydroxide to the products. To make sure that things stay balanced, I'm going to do the same thing to the reactant side. So 1 hydroxide to the reactant side. Alright, and then what's going to happen, the side that has both the H plus and the OH minus, right, those are going to combine to form water. So I could rewrite it at this point, but I think maybe it's easier, right? So instead of having 1 H plus and 1 OH minus on the product side, I'm going to have 1 water on the product side. All right, so I'm going to scribble those guys out, right? They're gone, right? Instead of an H plus and OH minus, I have a water. All right, but now I have 1 water on the products. I have 2 waters on the reactants. So this water will cancel. Instead of having 2 waters, I'll just have 1. All right, and so now we'll collect all of my reactants and all of my products. And so the final balanced reaction in basic conditions will be, I've got 1 water left, 2 aluminums, an NO2 minus and the hydroxide. And on the products, I have 2 AlO2 minus and an ammonia. So my reaction is now balanced for basic conditions, but it's still a good idea. Let's double check and make sure that everything has remained balanced. So I've got 2 plus 1, I've got 3 hydrogens, 3 hydrogens. I have 1, 2, 3, 4 oxygens, 2 times 2, 4 oxygens, 2 aluminums, 2 aluminums, 1 nitrogen, 1 nitrogen. So the atoms are balanced. As far as the total charges, I've got -1 plus -1, so I've got -2 on the reactants. 2 times -1, I've got -2 on the products. So my redox reaction is balanced in basic conditions.